Alright, let's talk about trigonometry and bearings. One of the challenges we have as we work in some application problems with triangles is setting up our triangle properly. And so we just need to know a couple things about bearings and kind of orientation, how we set these up. So let's look at a couple examples and discuss a couple of things. So first of all, a bearing, okay, which is commonly used in surveying, also navigation, measures the acute angle a path or line of sight makes with a fixed north-south line. So here's the key. We always want to start with our nice north-south line. So here's a few examples. So there's my north-south line. Imagine that's nice and straight, right? And of course, we'd have north, we'd have east over here, and we would have west over here, north, east, southwest. So if we see here, and we could go ahead and draw in our east-west axis as well. South 35 degrees east, so it's south. So if we're starting here, kind of the center position, that means we're heading south and we're going 35 degrees east. So I'm rotating out 35 degrees toward the east. So that would be something like this, and this angle right here would be 35 degrees. So I rotated 35 degrees toward the east direction. Okay? How about this one? North 80 degrees west. So I'm heading north, west. Again, let me do my east-west here. Maybe it's just easier for us to visualize. North 80 degrees west. So I'm heading in a direction like this. We rotated 80 degrees from the north line toward that western horizon, if you want to imagine like that. And then you can set up your triangles where you may end up, like in this case, you may end up drawing your triangle right there. So you don't want the 35-degree angle, you want the 55-degree angle right here, right? The reference angle. But this helps us draw them. This one, again, I'd encourage you maybe pause and see if you can't draw this on your own. So north 45 degrees east. So of course here's my east. So we're going like that. So we rotated 45 degrees from the north line. From the north line we rotated 45. Of course these would both be 45 in this case. Here's another common way that we describe things. This is primarily for air navigation, but we describe straight up bearings. They are measured degrees clockwise from north. Now normally we measure angles counterclockwise, right? But when we're doing bearings, we measure clockwise. It's just the way that it is. So I know sometimes that's frustrating. Well, why do they do it that way? It's the way it is, okay? So let's look at a couple examples. So again, let's say we've got our north, south here. We are going to go clockwise. So if they just say, hey, a bearing of 60 degrees, you start due north and you're just going to rotate 60 degrees clockwise. So it would be something like that. This would be the direction that we were headed, okay? 120. And sometimes when I do these, I haven't modeled this yet. I like to do a dotted line actually, kind of as my north-south axis. And so 120, again, I'm going to rotate, and if you want to do even something like this, just to picture your coordinate plane, right? So here's my due north, 120, so I'm going to rotate 120 clockwise. So there would be 90, go another 30, so something like that would actually be the direction that object was going. So like that, right? And that would be 120. If it was more than 180, it would be over here in the third quadrant. More than 270, it would be up here. So you just keep rotating, and then you can draw your reference triangle, and you've got a right triangle, you're good to go. Let's look at a couple examples. I'm not going to solve these out, but I'm just going to help kind of visualize how we could draw these. And again, I'd encourage you to pause the video based on what we just talked about, see if you can't set these up. One big thing with these, I would leave myself plenty of room. Don't kind of paint yourself in a corner, because there may be information there. You may be drawing lines in directions you weren't anticipating. So leave yourself plenty of room. A ship travels on a north 50-degree east course. Okay, so let's just kind of picture that. So here's my dotted line. Let's just start here in the middle. A ship travels on a north 50-degree east course. So that means it's doing something like that, right? And that is a 50-degree angle from due north. It travels until it's due north of a port, which is 10 nautical miles due east. So let's draw this. So it travels until it's due north of a port. So here's a port down here, right? And if we want to label them, whatever you'd want to do, which is 10 nautical miles due east. So it started here. That's 10 nautical miles. And now we've got that 50, so that means this would be 40. Hey, now I've got an angle. I've got a right triangle. I've got a side. I could use SOHCAHTOA. I could figure out any sides, any information that I wanted. How far did the ship travel? So in this case, it's asking for the hypotenuse. So again, my purpose here is not to solve this out. I think you can feel comfortable solving right triangles. It's drawing it, setting it up correctly. Okay, one more. George spots a campfire a bearing of 42 degrees from his current position. Again, let's give ourselves plenty of room here. I'm just going to kind of do my dotted. At a bearing of 42 degrees from his current position. So let's say George is right here. He spots a campfire 42 degrees from his position. So notice there's no north, east, south, anything. So this is going to rotate clockwise from due north. So 42. So he sees a fire somewhere out here, 42 degrees from due north. Fred, who is 3,000 feet due east of George, so due east would be straight out here somewhere, right? And this is 3,000 feet. Reckons the bearing to be 340 degrees. So if we do it from his position, he goes 340. Now all the way around would be 360. So he's something like that. So I'm going to draw that one a little higher just so they connect. So 340 means that this is a 20-degree angle right there, right? Because all the way around would be 360. So he almost went clear in a circle. So 42, and now we could use, if that's a 20, that means that's a 70. If that's a 42, that means that's a 48, right? And now I've got angle, side, angle. I could get this other angle as well. Now I can use law of sine, something like that, right? We draw our triangle, label it correctly. Hey, we've got tools. We can go solve things like this.